Hello, and welcome to the Gestalt IT On-Premise IT Roundtable, the only podcast that dares to be both on topic and on location. My name is Tom Hollingsworth, and I'm a part of Gestalt IT, and I'm here with a group of networking luminaries to discuss a premise or an idea that we have in today's technology world. And I'd like to take a few moments for the guests to introduce themselves before we get to today's premise. Kevin?
Hi, my name is Kevin Myers. I'm a senior network architect at IP Architects, also a co-founder, and you can find me on Twitter at stubarea51.net.
I'm Scott Morris, one of the founders and architects at Alchemy Global Networks. You can find me at Scott Morris CCIE.
And I'm Stefan Fouant. I'm VP of Technology and Engineering at Sun Management. We're a VAR based out of the DC metropolitan area, and you can follow me on Twitter at sfouant.
All right. Thank you very much for joining us today. So let's get to the premise for today's podcast. Unless you've been living under a rock for the last 25 years, you've probably heard about IPv6. It's the next biggest thing to be happening in networking. It's going to fix all of our addressing issues, and it's going to make the world a happy, bright, shiny place. And the fact that we're still talking about that 25 years later tells you that we're not quite there yet. And we've been talking about a lot of reasons why IPv6 hasn't been widely adopted. But one of the biggest issues that we see cropping up is administrative problems. So the premise for this episode of the podcast is that the biggest adoption roadblock to IPv6 is administrative. Now, Kevin, before we started the podcast, kind of the idea that kicked this all off for us was we were talking about the fact that regional internet registrars, RIRs, have been handing out large blocks of addresses, /48s, which is a large number of addresses. And this kind of harkens back to the days when we were talking about IPv4, where they were handing out very large blocks of /8s, which was, something like 16 million addresses. And at the time, we didn't think it was a huge deal. And now in 2019, when we're completely out of address space, we realize it's a huge problem. So why is something as simple as an administrative decision to hand out large address blocks going to cause so many problems?
So I think there's a few reasons. We've gone through this big journey in IPv6 where we started way back in the day and we said, okay, here's going to be the guidelines, here's how we're going to do subnetting, here's how we're going to hand it out to the end user. And that's kind of morphed, and we've been through this big journey of seeing that change over the years. And now we're in a spot where I think we've got some good guidelines, but you still see a gulf between, I'll use North America and Europe as an example, where if you're in North America, the current practice is let's give everybody a /48, whereas if you're over in RIPE's territory in Europe, it's, well, let's maybe do a 56 instead. And so you see these variations in practices that can make it confusing if you're trying to consume IPv6, because both have valid points, but it's, well, which model do I go with? And so there's certainly a lot of addresses, and I don't think we're running out of addresses, but the challenge with v6 is figuring out your addressing plan and your subnetting plan and how you get that down. And the conflicting information that's out there can make it difficult, if you're not familiar with v6, on which one should I go with and why.
Right.
If I can just dovetail on that, I mean, you talked about in America, /48, and in Europe, /56, right? And I would argue that even the /56 is far too many addresses for most organizations, and I just wish we would adopt more practical measures as far as what is realistic as far as address usage for a typical enterprise organization, and let's adopt something that's a little bit more practical as far as doling out IP addresses, because we're going to end up running into the same problem that we ran into.
Well, I mean, one of the fun things is, though, you got to look back at history. So, I mean, again, back in the 90s when they came up with this stuff, the original set of premises for how to do this, so the RIR model, was that, everybody, supposedly the enterprise would get a /48, your ISPs have a /32, your regional registries be a /16. So everybody was kind of on this, we're going to just roll up, we're going to have great summarization, the global routing table going to be really small, no problem, except for the fact of multi-homing.
Yep.
Back in the 90s, not really so much a thing. Today, all over the place, even at small levels. So we've got a whole different set of ideas now, not just on the really how many addresses do you need, but to what we're going for in terms of the reason things were laid out like that honestly doesn't apply to today's reality. And nobody's gone back and, at least from a high level, redone it. But I mean, even at that point, it still might be too late. One of the funny things, so I have IPv6 addresses, and of course, right?
Right.
Because I can. The funny thing was, I tried to get a /48,
right,
and was told no because I'm already set up as an ISP. I had to have a /32. I have no need for that many addresses. I mean, even to /48, even I don't have that many subnets. But it's just the way that the rules were, that's what there is. So if anybody needs anything, I can sub-allocate, not a problem.
But that's actually one of the problems that we run into when we look at the history of things, because we're all familiar with IPv4's Class A, Class B, Class C. You know, one size fits most for address space. And we learned a hard lesson, because now when you look at the modern internet, it's full of NAT and conserving address space and resell on the market and things like that. So we should have in the 90s said, okay, well, let's not do that with IPv6. But the problem is that when you have something like, 15 quintillion addresses available in the space, what's the first thing you're going to do? I'm going to carve out the biggest blocks that I can. So when you look at the original administrative decisions, such as end hosts will be /64s, even though a MAC address is 48 bits, when you look at the fact that we're blocking off very large portions of the upper areas of the internet, so like 2002::/4 is a globally routable address for all of these things. Or we set aside an entire /8 for Teredo. Why?
Seems like a good idea at the time.
And I think ultimately that's the problem, is when we start making these decisions initially, it seemed like a really good idea at the time because we're overflowing with address space. And 15, 20, 30 years from now, if we're still using IPv6 and haven't moved to version 8, we're going to run into the exact same problems again, because the decisions that we made, or that our forebears made, are impacting our ability to fix things today. So how can we fix that? Is there a way that we can fix that?
Well, see, the problem, one of the problems I see with it is not just, making a standard, diverging from it, abandoning it, or ignoring it anyway, pretending it'll go away, or not worry about it. But even as we go down any path, I liken a lot of the I'll call them admin issues of IPv6 or confusion of IPv6, same way in IPv4. There's still a whole bunch of people today who can't figure out how to subnet IPv4 correctly. And you're going to IPv6 and introducing letters? Really?
Yeah, I agree. I mean, just to dovetail on that, I mean, the education component is going to be huge, right? I mean, so it gets exacerbated when we move to V6 with, quad.
Well, and not only that,
hex and quad addressing and all that stuff, right? So.
If you look at what you were talking about in subnetting v4, we're in this space now where /24s in the global table are exploding, and we're almost at 800,000 routes. When I first started paying attention to v6, the global table for v6 was 32,000 routes. It's at 77,000 routes now. But the thing about v4 is we at least have a limit that we can hit. We cannot get over a certain size. I mean, with v6, it's practical infinity, from a practical standpoint, because how many /48? /48 is the new /24. How many of those can we dump into the global table, and what's that going to do to our entire global network architecture for the internet when we suddenly, I have a global routing table of 10 million routes. What am I going to do with that? That's a challenge that I think we're going to get faced with sooner than we think, and nobody's really talking about that, the v6 explosion of the global table.
But let's back up a minute, because you're kind of hitting on a key there. From a mathematical perspective, v6 is essentially unlimited, because there's no way that we're ever going to run out of that many addresses anytime soon.
I was like, careful, they said about v4.
So we have nanites, then we have nanites, and we're getting every nanite in the body of v6 address.
But remember, if you want to rewind the clock all the way back to the early 90s, I mean, I can still remember taking tests where they referred to OSPF as an expensive routing protocol because of the amount of memory it consumed. Yeah. And how long did it take us before we finally had a router big enough to load a global BGP table in RAM to be able to do work on it? Look at the number of ways that things like TCAM memory are horribly expensive. And even when you look at it, it's basically built to hold a 48-bit address in a TCAM entry. We use hardware and optimize it to do things a certain way. So I know that if the global IPv4 routing table is a certain number of bytes, I can contain that in a router with enough memory. I can't build a router big enough to hold a fully populated v6 routing table. So again, administrative decisions that we're making are hampering adoption because I can't build a router big enough to hold all of that information right now. And there was even a bug in software a while back.
You could play devil's advocate and say, like a lot of this is kind of the drive for pulling the control plane out of routers and bringing them into like x86-based platforms where you can scale memory a lot, easier than like on like physical, platforms, right? So I mean, I think there's some argument there that that might not necessarily be a limiting factor. But I hear you. If you're running this on a physical platform, TCAM memory and all that kind of stuff is very expensive, right?
But one of the other problems we run into is it's not just the physical hardware platform. Software is not built for this. There was an issue with, I believe it was Cisco code a few years ago, where loading v6 entries into the routing table actually doubled the amount of memory it should take.
Yep.
I believe it was for MPLS, because it had to create an extra entry for a certain tag, and that exhausted all the memory way before it should have, because somebody doesn't know how to write good code. And I'm not saying that that's specifically anybody at Cisco. We all have problems writing good code. But these are the kinds of things that we have to keep track of as we move along, because a little bug that gets introduced today may not be found for 10 more years until we hit that magical checkpoint of an overflow.
Yeah.
So how do we adjust our administrative policies? Is it going to be incumbent upon people like the RIRs, like Aaron and Ripe and Apnic, to make these choices? Or do we as end users have to push back against the administrative people and say, it needs to look like this or you're going to get it wrong?
I think honestly, when it comes to the the organizations like the RRs, they've done a lot of great work in promoting V6 and getting it out there. But I often find that there's sometimes a gulf between what is the accepted practice and what you have to do in reality for your use case. And I think that's what it always boils down to for engineers, is that the use case for enterprise versus service provider versus industrial government, they're always different. So you've got to look at these and understand, okay, Aaron has this view, Ripe has this view, what am I trying to do? And get down to a practical use case and not get hung up on the fact that you've got to make it look exactly like this RIR says that it needs to be.
Well, and right now, I think we're insulated by some of the Band-Aids out there. Because, I mean, kind of like what you're talking about the size of the V6 routing table. My end-to-end IPv6 transit is very small amount of bandwidth on the actual internet itself. So if you look at everything from my cell phones to my MSOs, my cable providers, telcos, everything like that, that is using V6 because they don't have enough addresses, good on them, but there's a whole ton of carrier grade NAT going on.
Right.
And that's exactly where things are. So there's a lot of insulation where okay, so Verizon, pick a company, but they have this problem and their routing table is this size, so here's their answer for it. And they can handle the amount of routes that they have. Whereas we go over to, Cox or Spectrum or, again, pick somebody else, AT&T, they have theirs, which has nothing to do because they could care less about Verizon's IPv6 addressing because it's all natted in between, and they've got their own problems. So everybody's in this little insulated view of looking at it until we actually get to a point, and I hate to be the naysayer on this, but until the world burns and the internet goes down because of something like that, nobody's going to be motivated to say, hey, guess what, guys? We either need to change this or make a bigger router or decouple.
So allow me to put on my horns and become the devil's advocate here. I have talked to John Curran at Aaron about how we had to rewrite FTP to be NAT aware because it embedded a string literal in the packet. And that was the day that the internet should have caught on fire and burned, but we fixed it. Or how Xbox Live was going to be the reason why we went to V6, because you can't do end-to-end encrypted voice chat with Xbox Live packets because they're not NAT aware, until we fixed it. The problem, and this comes back to an administrative solution, is that right now it's cheaper to just make NAT work a little bit better with what we've got than to do a rollout. When you look at the number of people who are trying to advocate for V6 deployment, for switching services to DNS so that we're not relying on the underlying infrastructure, even companies like Apple who are mandating V6 addressing in their apps to have them be able to be loaded into the App Store, it's still not enough, because ultimately, when it comes to administrative solutions, the cheapest solution is the one we always go with.
Yeah.
So how do we overcome that barrier?
I'd say make it easier, but I'm not sure that's entirely possible.
Yeah, I think the key is continuing to push forward. Now we're in true IPv4 exhaustion. Like, it really is here. There's nothing else. The price, if you pay attention to the price of IPv4 black market, like, it's skyrocketing. It did in 2018, and it's doing the same in 2019. So, I think as you're deploying new things into your network and new designs, you've got to look at the things that we don't look at. In your planning and your administrative planning is my management, my out-of-band management, my applications, all these things that we don't think about. You've got to start paying attention to and make sure that it's v6 capable, because it's not going to be a huge deal for a while. You can live on v4 private for a while and intermix, and I think we'll be dual stack for a while. But eventually, not having things natively v6 is going to come back to bite you, and it may be a while before that happens. But I think making sure that you're v6 aware in your planning and that that's the forefront of everything that you do is one of the things that you've got to start doing in 2019 if you're not already doing it.
Stefan?
Yeah, I mean, I just agree with everything they said. I mean, it may be performance implications at some point, of being able to remove NAT or something along those lines. I don't know what the compelling use case is going to be to get us off of a dual stack, but it could be just all the complexity that's involved with NATing and performance implications and all those types of things that ultimately may be what's sort of the kicker.
That becomes financial too, because CGNAT is expensive to run. I do a lot of carrier work. I'm involved with a lot of CGNAT solutions that I've got on my slate right now, and CGNAT is not the cheapest thing in the world to roll.
Yeah, and
so if you're
at the end of
routing,
the end of the day, to do CGNAT, what do you need? You still need a v4 address, right? And if we truly are at the end of the line here, where we're experiencing true v4 depletion, then eventually we're not going to be able to.
And that is the hard part. Because I mean, the interesting thing about that is, okay, so yes, it's not simple to do CGNAT, and there's a cost to it. But is that cost more or less, kind of like what you're going for, cheapest solution, than renumbering, redoing everything you already have, making sure everything still works, and getting into some sort of a solution method, hierarchy, if you will, but again, something that how many of my devices do I have to replace if we go to v6 everywhere? I look at that and go, that has to be more expensive. So therefore, more NAT and Band-Aids all over the place.
And it depends on the realm that you're in. I mean, I do some enterprise, but I'm very much in the ISP space. So ISPs, and I work with a lot of small, medium ISPs, are starting to realize that I don't want to just keep going and buying from the black market. So from their standpoint, they definitely see the value, the business value in v6. And to the point of the administrative functions, that has a business impact as well, because if I get a 32 and I just hold on to that 32 and subnet it the way that I need it, I don't have to go back for more allocations from the RARs. Where if I do it, if I'm doing it and I'm just throwing them out as much as I can for a small business, if you're a large business, maybe you don't care that you got to pay $20,000 or $30,000 in registration fees to the RARs. But if you're a small business, that's a consideration. That's something that you've got to put in your business.
Well, but even in that, keep in mind though that having a /32 technically limits you to 65,000 customers.
Yeah.
If I'm giving out a /48 to
Well, that's what we're finding in the ISP space is that I actually have customers that's a boundary, and we've got to go over that.
Right. And I mean,
that was why it came up in conversation.
For small ISP, that may be no big deal, but I mean, I'd kind of like to have more customers.
If you're handing out a 56 or something else, it's usually not as much of a challenge.
Right.
But if you're handing out a 48, you burn through those a lot faster.
Right. Yep.
All right. Well, I think ultimately what this comes down to is business drives the use of technology. So whether it's the coolest new protocol or whether it's the most awesome piece of hardware you've ever seen, ultimately, if it doesn't serve a business role, then it's useless. But business roles have policies attached to them. And if we don't make a business policy, we don't have a use case, and we don't have a need for technology. So ultimately, we have to look at the way that we use our administrative policies in our business to support the technology that we're deploying. And sadly, as it turns out, we're never going to have the perfect administrative policy for every use case. So you have to make sure that you pay attention to what you're doing, think smart, think forward, so that 20 years from now, we're still not arguing about why we haven't adopted IPv6. All right, that will just about do it for this episode of the On-Premise IT Roundtable. If you'd like to see this episode or possibly other great episodes of our podcast, you can always find the latest at our website at gestaltit.com/podcast. You can also find us in your favorite podcast application of choice and on iTunes. If you find us on iTunes, please leave us a rating and possibly even a review, because that helps the podcast spread around to other great listeners and helps the audience grow. And if you have a premise that you would like us to debate here, please make sure you send it in to us at gestaltit.com. We're always happy to discuss more interesting applications of technology. But for now, for our fine podcast guests, for all of the great people at gestaltit.com, we wish you a great day and keep listening.